Hello students, today we are going to see force and acceleration. Take a glass marble and let it roll on a big smooth tabletop. After some time, its velocity will decrease and it will stop. Now a carom board too, the carom coin pushed by a striker will move forward some distance and then come to stop. If we apply talcum powder on it and if the coin is pushed after applying talcum powder to the carom board, it will keep moving for a longer time and then come to a stop. The velocity of the coin decreases due to the force of friction and the coin stop if the friction between the carom board and the coin is reduced. Why it is reduced? Because we use talcum powder. The coin keeps moving for a longer time. It would mean that if no force of friction is acting on a moving body, it will keep on moving with a constant velocity. The scientist Sir Isaac Newton was the first to study force and resulting acceleration. He proposed law of motion. Now let us see Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. In other words, if a body is stationary, it will remain stationary. And if it is in motion, it will continue moving with the same velocity and in the same direction. After understanding about force and acceleration, let us now define unit of force. If 1 kilogram standard weight on a surface with no friction and pull it with an acceleration of 1 meter square, the force applied is called 1 Newton. Newton is the SI unit of force. So here we get the unit of force. 1 Newton is equal to 1 kilogram meter per second square. We know that acceleration is a vector quantity and the force is also vector quantity. According to Newton's first law of motion, when force is applied on an object, acceleration takes place. The effect of force depends on both magnitude and direction. The force can increase or decrease the velocity. Sometimes the magnitude of velocity may remain constant, but their direction of the velocity can change, which shows that force is also vector quantity. Come, let us do one activity to understand relation between force, mass and acceleration. Now, see the activity on page number 49. Try this. Let us spread talcum powder evenly on surface of wooden table and place a weight of 1 kilogram on it. Let's now pull the weight with an acceleration of 1 meter per second square. Since 1 kilogram of weight is pulled with 1 meter per second square, the force applied is 1 Newton. Now pull it with 2 meter per second square. This means that force applied 2 Newton from this. So you must have surely understand that force is measured by acceleration that it produces. So we know that force is equal to mass into acceleration. We have learned about the relationship between the displacement of a body resulting from the force applied to it and the work done. We have also learned about the work-energy relationship and that the ability to do is called energy. Now the relationship between the force, displacement and work we will see in our next lecture. Thank you.